Assalamualaikum and hi. We continue our discussion on inverse of Laplace transform of rational function. When we talk about the rational function, we actually want to say about the partial fraction. Okay, partial fraction is when you have a polynomial function. Okay, you have a rational function and you have polynomial function at the numerator and your denominator, and you will find that your denominator, the degree of your denominator is greater than the degree of your numerator. Okay, so that we try to form the partial fraction, then we find the constants, and then we take the inverse of Laplace transform. That is the idea. Okay, basically these are the most important thing in partial fraction. I don't want to discuss about this. I just go on and proceed to the example. Okay, because you already know this one from matriculation, from your STP, and even during your math one. Okay. Okay, so now in inverse of Laplace transform by using partial fraction, of course, the first thing is you must have a fraction. Okay, you must have a fraction or rational function, your numerator and denominator in the form of polynomial, and then we want to form a simpler function by using partial fraction. Okay, let's say we have 1 over s plus 1. Okay, 1, this one is s to the power of 0. Okay, the degree here is 0, but the degree here is 2. S times s is s squared, the highest degree is 2. So your degree of your denominator is greater than your numerator. So we want to apply the partial fraction. Okay, so take the Laplace inverse of this one. Okay, so that we know that we can apply partial fraction here. Okay, because we have we have a quadratic function here. Okay, we have a polynomial function here, and then we can obtain perfect factorization. You have a whole number like this. S plus 1 is s. Let's say you have s minus 0 or s plus 0 times s plus 1. So you have whole number here, 1 0. Okay, when you can factorize this function nicely. Okay, I say this one is nice lah, nice number. Okay, so that you need to apply partial fraction. It's better if you apply partial fraction. But if you have something like the previous video, okay, let's say you have over s s square plus 7s plus let's say 9. Okay, something over this one, your quadratic function is s square plus 7s plus 9. Obviously we cannot get whole number when you try to factorize. So that in order to factorize your denominator, you apply the completing the square technique. When you apply the completing the square, means that you need to apply first shift property. Okay, when you apply completing the square, you must apply first shift property. But your denominator, when you factorize, you get a nice number. You have a whole number like this. So better apply partial fraction. So that is the tip. Okay. So now I try to solve this one separately. Okay. By using partial fraction, I have this one. By using partial fraction, I have this one is s to the power of 1, which is a linear. So I have a over s. S plus 1 to the power of 1, still a linear function. So I have b over s plus 1. So what we do is we try to cross multiply this one. Okay, we cross multiply so that I have 1 at my left, on my left. So this one, I have a times s plus 1, so I have as plus a plus b times s is bs. Okay, where your denominator is s plus 1 because you already cross multiply. Okay, so we share the same denominator now. So we don't want to compare this and this because you have the same thing here. So what we compare is this one. 1 equals to AS plus A plus BS. I will collect the same term. Okay, the same term. So I have S. Okay, my right hand side I have A plus B, but my left I don't have the coefficient of S. Okay, so that I have 0. So S to the power of 0 or just a constant, I have A on my right. It's just A. A equals to my left hand side I have 1. Therefore, I can conclude that my A equals to 1. When A equals to 1, therefore my B equals to negative 1. Okay, so this is my constant. So I try to put it here. My A is 1, so I have 1 over S minus 1 over S plus 1. And I will copy this one. This one is the simpler function by using partial fraction. I can conclude that, oh, my Laplace inverse of 1 over S times S plus 1 here can be simplified in the form of Laplace inverse of A over S, which is 1 over S. Okay, by using linearity property, I try to split this one into simpler form. So minus this one. So we have plus B over S plus 1. Okay, so B is negative 1. So I have minus Laplace inverse of 1 over S plus 1. So that you can refer the table of Laplace transform. 1 over S is 1. So minus 1 over S plus 1 is E80. Okay. We take out E80. E negative T. Okay. A is negative 1. Okay. So I take the Laplace inverse of the remainder, which is Laplace inverse of 1 over S, which is 1. So this is our solution. By using partial fraction, we try to simplify your function. We try to simplify your rational function. Okay. Let's say we have this one. Okay. Take the Laplace inverse of 1 over S minus 2 S plus 3. Okay. So let's say I can ask you, initially the question is 1 okay over S squared plus 5S plus 6. Okay. What you need to do is you try to factorize your denominator, because this one is polynomial. This one is also polynomial. When I try to factorize this one, your denominator, what we get is we can get whole number like this. This one is S minus 2. Sorry, this one is 1 over S plus 2 S plus 3. Right. Okay. So we have whole number here. Okay. When you have whole number, so that we can apply partial fraction, since your denominator and numerator are polynomial. Okay. Polynomial function. If you cannot get whole number when you try to factorize, try to factorize your denominator by using completing the square technique. When you apply completing the square, do not apply partial fraction. You must apply first shift property of inverse of Laplace transform, because first shift property is much easier than the partial fraction. Okay. So now, let's consider this one. Okay, I have S minus 2, S plus 3. So that I try to solve this one separately. So I have 1 over S minus 2, S plus 3. Okay, equals to, this one is a linear. So I have A, S minus 2, plus this one is also a linear, B over S plus 3. So we try to cross multiply and compare left hand side. I have 1. So I have AS plus 3A plus BS minus 2B. Okay. So I continue. I try to collect the same term. I have for S, I have A plus B equals to 0. For S to the power of 0 or just a constant, I have 3a minus 2b equals to 1. I don't have calculator. You just punch your calculator to get A and B. Don't waste your time and don't waste your energy to get A and B because the marks is just 1. Okay, so A equals to negative B. Okay, when I substitute here, I have negative 3B minus 2B. Okay, negative 3B. Okay, betul. 2B equals to 1. So negative 5B equals to 1. I hope that I calculate this one is correct. Okay, negative 1 over 5. When B equals to 1, negative 1 over 5, therefore A equals to 1 over 5. Okay, alright. When I obtain A and B, then I substitute back into my partial fraction. Okay, so I have A is 1 over 5. 1 over 5, 1 over S minus 2. Okay, right. Plus B. B is negative 1 over 5. Negative 1 over 5 times 1 over S plus 3. Okay. Make it simple. Right. So that what I can say is Laplace inverse of 1 over S minus 2 S plus 3 is equivalent to 1 over 5 Laplace inverse of 1 over S minus 2. I just take out 1 over 5 because it is just a constant. Okay, so minus 1 over 5 Laplace inverse of 1 over S plus 3. Okay, as you can see, this one you can refer the table, or you can just apply first shift property here. So I have 1 over 5. 1 over S minus 2 here is S minus A. So I take out EAT, E2T. So I erase the A. So I have to take the Laplace inverse of 1 over S. So which is 1. So it's enough. Minus 1 over 5. 1 over S plus 3 is 1 over S minus A. So your A is negative 3T. So I take out EAT. So take the Laplace inverse of 1 over S, which is 1. So this is your solution. Okay, so that is how we apply the partial fraction to solve for inverse of Laplace transform. The first thing is you must have the polynomial function where your degree of your denominator is greater or higher than your numerator, and then try to factorize. Try to factorize your denominator. If you get whole number, very nice number when you try to factorize, then you apply the partial fraction. Okay. Find your constant A, B, C, and whatever constants that you form in your partial fraction, and then take the Laplace inverse, refer your table. So that is how we apply the partial fraction. Okay. Now let's take a look at this one. Let's say you have this one. Okay, so take the Laplace inverse of 3s minus 4. For this time, I don't want to take out any constant out from my Laplace inverse because we want to compare the constant here and the term when we form the partial fraction. So just let 3s minus 4 inside your Laplace inverse. Okay. S squared minus 16, I can see that I have s minus 4, s plus 4, right? Okay, so I have s plus 4, s minus 4, or just s squared minus 16. Okay, so what you can do is, this one is 3s minus 4, s minus 4, s plus 4. This one you need to continue, okay? I have this one is linear, and this one is also linear. So I have A over S minus 4 plus B over S plus 4. You just cross multiply, get the value of A and B, and then put it back on A and B. Take the Laplace inverse, this one. Okay, so you have the solution lah. Okay, but for this one, let's say you have S squared We don't care about your numerator. This time we want to know how to form your partial fraction by looking or considering your denominator. S minus 1, S square plus 1. So I have this one is a linear, so I have A over S minus 1. Okay, but this one is a quadratic function, so we must have bs plus c over s square plus 1. So you just cross multiply and then compare the terms to get what is the value of a, b and c, and then put it back into a, b and c. Okay, let's say your a is 1. Let's say okay, a is 1, b is 2, c is 3, so that when you try to get the Laplace inverse, so it becomes this one. A is 1 and just now, so 1 over s minus 1. B is 2, so you try to apply linearity here, so you have plus 2 Laplace inverse of s over s square plus 1. Okay, now apply linearity. Plus c is 3, so plus 3 Laplace inverse of 1 over s square plus 1. So get the solution. Okay, understand? Alright, so what else? Okay, let's say this one, 1 s square s plus 1. Okay, let's say you have to take the Laplace inverse of 1 over s square s plus 1. Okay, so I try to solve this one separately, form the partial fraction, so I have 1 s square s plus 1. Okay, equals to, this one is s square, means that you have a times s times s tau. So this one is a repeated linear, so you have a over s plus b over s square. Plus this one is just a polynomial, memanglah polynomial kan. So s plus 1 is linear function, so you have c over s plus 1. So how to cross this one? The first thing is okay, make sure that you know that we want to share the same denominator. You want to share the same denominator, so that your denominator must have s square s plus 1 tau. Okay, s square s plus 1, but look at your a. You just have a over s. How to get s square and s plus 1? So apa yang lack dekat sini? Okay, the lack one is you must have another s and s plus 1, so that you have s square s plus 1. Okay, so next, plus b. In b, you have s square, but you suppose have s square s plus 1. Apa yang lack dekat sini? S plus 1, right? So you must multiply this one by s plus 1. Then you have c. Your c here, you have s plus 1, but you must have s square s plus 1. So the only thing that lack here is s square. Now, let's take a look. We try to check our function, okay? Either we have original function or not. Okay. S plus 1 is, when I try to cancel out here, I have s plus 1. So s plus 1, I cancel out. So I have a over s. Then I get the original function back. B s plus 1, when I cancel out s plus 1, I have b over s square. Okay, then I get the original function back. C s square over s square s plus 1. So s square and s square cancel out. So I have c over s plus 1. This is my original function. So it means that we do correct cross multiply here. Okay, so I need to copy this one back. So I have a s times s plus 1. So a s square plus as plus bs plus b plus cs square. We don't want to compare the denominator because the denominator is just the same thing. Okay, so s square, compare the term s and constant s to the 0, s to the 1 and s to the 0. For coefficient of S square, I have A plus C equals to 0. We don't have any term of S square here. Okay, for S to the power of 1, I have A plus B equals to 0 also. Okay, this one. And S to the power of 0 equals to B. B equals to 1. Right. So B equals to 1. Betul ke saya buat ni? I hope that this one is correct. Okay, alright. So B equals to 1. When B equals to 1, we can conclude that A equals to negative 1. When A equals to negative 1, so C equals to 1. Okay, I hope that I calculate this one correct. Otherwise, you try to punch your calculator to get A, B, and C. If I did wrong, so you just correct the value of A, B, and C. Okay, then after I get the value A, B, and C, I go back to my partial fraction. I can conclude that Laplace inverse of 1 over S square S plus 1 is equivalent to Laplace inverse of A over S. My A is negative 1. So negative 1 over S. Okay. Plus B over S square plus B. Plus B is 1. Laplace inverse of 1 over S square. And the last one is C. Plus Laplace inverse of C equals to 1. So 1 over S plus 1. Okay, so this one is a very simple function. You just refer the table. So this one you have negative 1 over S is 1. Okay, then you have plus Laplace inverse of 1 over S to the power of greater than 1. You must refer T to the end. So this one is T. Plus this one is S is replaced by S minus A. Take out E negative T. Delete or erase your A. So I have to take the Laplace inverse of 1 over S, which is equals to 1. So this is your solution. Okay, that is the end of properties of inverse of Laplace transform. After this, we want to discuss or we want to apply both of uh, Laplace transform and inverse of Laplace transform in order to solve for IVP, which is initial value problem. Initial value problem is a differential equation combined with the initial condition. So that is our ultimate goal. Yes. Okay. Thank you, class.